Hello, this is just going to be a quick video going over object detection with Tensorflow Lite. Now, almost all of the code is made for us, so you know it's going to be fairly easy. So let me go over this. Now, first of all, setting up your camera on the control hub. All you're going to do is connect your camera to the USB port and go to robot configuration and click scan once you get into your configuration. And a little webcam 1 if you have one webcam connected, maybe webcam 2 also if you have 2 connected, they should pop up once you click scan, you know. So next, we're going to be working mainly with this code right here, concept TensorFlow object detection. Now this is the basic code they give us for object detection. You can find it right here in the robot FTC robot controller, Java, whatever this says, and then external samples, and you should find it right there and just open it up, you know. What the heck? Alright, there we go. So next, as you can see, it has a ball, a cube, a duck, and a marker, so everything's made for us already, you know. That's really nice. Now this does use the engine vuforia, so you will have to get a vuforia key. Now this is a really simple process, so you're just gonna type the link. You're gonna first of all, you're gonna make an account on this, and then you're gonna, you know, sign in. Once you do that, you're gonna go to develop list manager, get basic, type your little whatever you want to call it. Please put a descriptive name, don't put this. You're gonna do that and confirm, right? Now I will, and it's gonna give you, by the way, this like this really long weird thing. You just copy and paste that key into this, you know. So I will be putting my key in the description, but please, I recommend a lot to use your own key, because I'm not sure if this means that it has a limited use, because if it does, yeah, you don't want to go to a competition and like be like, my key, it ran out of usage. So it's better if you get your own key. Next, you're gonna initialize vuforia, the localization engine, and next you're gonna initialize the detection engine, aka TAFODs, and this is where you're actually gonna like call the methods to get any detections, right? To find the objects. Now here you're just gonna do init vuforia and init TFOD. So after you do that in the runout mode, you're gonna just, if TFOD is not active yet, you're just gonna activate it, you know, TFOD.activate, and that's just so you can start detecting objects. Now next you'll see this TFOD.setZoom, and this is very important, because let's just say zoom is actually probably the most important thing in this. Now here's the thing, right? If you want, you could legit just focus, like, yeah, sure, your camera could be seeing a lot of stuff, but you could just focus on like a little part of the camera, right? Now here's the thing, you know, about this. When you have a really big zoom, like imagine, like in our cases, a set zoom 1 is the lowest you can have. That means legit you're just gonna say, look at the whole camera, I don't care, alright? You're just saying, just analyze the whole camera. Now here's the bad part about that. The bigger your zoom is, like if it doesn't have like a constant background, I'm not sure if it's that, but I'm pretty sure it is that. Like if it does have like a constant background, it could get weird, you know. Detection could get a bit messed up, you know. So imagine your background is all black and then just duckies, that might be weird. If your background is just one color, it could be good. But in our cases, the field has a lot of colors sometimes, you know. So a full zoom like that is most likely it's gonna be a bit sketchy, you know. So in our cases, for our basic code, we're just gonna assume it works perfectly a-okay, but it's not gonna be very good. At least when I tested it, it didn't work very well, you know. So you might want to set a smaller zoom if you ever just want to focus on one little spot. Next, so the zoom, just remember, really important. The smaller the zoom, aka like the more you see of your camera, it can get a bit sketchier. So next, once you go, all this run up one doesn't matter. That's just, you know, to run it. You're just gonna make sure TFOD is activated here again, aka your detection engine. This is the part that really matters right here, as you can see. Okay, so right here is get updated TFOD.get updated recognition, and this is legit just say look at the screen and check if there's any objects, and if there's any, put them into a list. So the recognitions is an object, so it has like, you know, it has methods where you can call like values of it. So as you can see here, when they iterate through the recognition list, the updated recognitions list, they are getting recognition objects, and they're gonna do get label, which is gonna return either a ball, a cube, a duck, or a marker, depending on what it saw. And here's the good part: it returns the left top, aka what would be like this spot, and the right bottom, what would be this spot. Meaning, we know where our little ducky's gonna be. You know, we can know where our little ducky's gonna be, and that's really cool because that means essentially now all you have to do is, if you put your camera in a really good spot where like you can just legit split the screen into three, and you know each section corresponds to like one of the little like markers, and depending on which section your duck is most in, well, there you have it. That's where you should be putting it in the shipping hub. So you just like, you know, get your right bottom and left top coordinates, and that's basically, yeah, just like depending on where it is, like what coordinates you get, that's how you would do it. Now this is the basic way to do it, all right, but I'm not sure if I should call them better ways actually. Now what if you want to use two cameras? Because I don't know, you might want to. Then there's this next code right here, concept TensorFlow object detecting switchable cameras, meaning you can have two cameras now. Which the only reason you might want two cameras for is maybe if you wanna, like, you know about the zoom problem, like you might want to fix that by like having one camera just zoom on two and the other camera just zoom on one spot. That might be a way you want to do it. I don't recommend going for like three cameras. I mean, that's a bit extreme. Just maybe go for two, you know, like that's fine. So yeah, the one reason you might want to use two cameras is if you want to kind of fix the zoom problem, you know. Now I already explained all this. Now this is the new code right here. Webcam, you have your webcam 1, webcam 2. Just imagine this as hardware mapping, but instead it's now for webcams, you know. So here there's the switchable camera object. Now really just to know how to like switch between cameras, you're just gonna scroll down here and it says do a camera switch. All this code does not matter. This is just like saying like, this is just to like know which camera to activate depending on which bumper you're like pressing on the controller. This is what matters. Switchable cameras get activate camera, no, right here, this is what matters. Switchable camera dot set active camera as webcam 1. I mean, you can have two webcams, and with this code you can either activate the webcam 1 as your current camera that you're like looking at, or webcam 2. So yes, you can only look at one camera at once, but you can like toggle between them. So this is the really only code you need to know for like doing camera detection for two cameras. Now here's the thing, right? Now that you know all this stuff, how do I implement it? Well, in our cases, by the way, and this is important to the code I'm about to show you. Is it on here? I'm pretty sure it's here. Yes. Okay, so wait, is it? No, it's not this one. Wait, give me a moment. There we go. Okay, so here's the thing, right? I can have my little camera here. Now we're imagining it's not perfect. Like I said, you know, it's not perfect. Actually, I'll just look at this one because that one doesn't allow me to move the little ducky. So we have a little camera here, right? We look at an image, we analyze it. Our thing doesn't find anything at all, right? Actually, by the way, quick thing, right? After you set up the camera, you can't just run the program. Like, yes, you can run this. My bad. I'm very sorry. Backtracking real quick. Back to here real quick. You can't just like run your code and like run everything and then just like be able to see like what the camera's seeing. To do that, what you're gonna do, once you like on running code, you're gonna click in it. Once you do that, you're gonna go to the little like up thingy like settings where all the configure robot stuff and all those other options are, you know. and you're gonna click, and a little option should appear saying camera stream. You can click that, and with that you can essentially like just keep clicking the screen like to see the new updated like version of what your camera is seeing. So that's just to actually be able to see, you know, what your camera sees. Moving on back to where we were, right? So here's the thing, right? You can run a detection, like you can run a detection on the camera, and it won't find anything. You can run it again, and it won't find anything. And you can run it a third time, and it'll find something. Like this can actually happen, you know. Like you can run it, and it won't find it. It's not something that's consistent, you know. It's once it detects it, I'm pretty sure it'll keep it detected unless you move it. Then it's gonna have to redo the process. But just know that once you do one detection, it's very unlikely that it's going to find it the first try. So you might want to run various detection. And this is where the actual auton code comes in. As you can see, autonomous. Ooh, cool. Very nice. So there's the sample code I use to like do that, you know. So let's forget about this test servo for now. Just imagine we have our camera set at one spot, right? And we want to imagine we just have our camera set at the top of a robot and we're being able to see everything. You're not just gonna want to run one of these like get updated recognitions, you know, because it's very unlikely you'll find out on the first one. So you might want to use, okay, don't use recursion. It can be sketchy. Recursion is sketchy, all right. So you might not want to use recursion. But in my case, this is the code I'm using, and I've never tested this. I'm hoping it would work. I'm not sure. All right, so what you would see is you're gonna run find duck, and you're gonna give it like a number of tries. All right, I named it tries left, but it's really you just type a number like 10. Give it 10 tries, like analyze the screen 10 times, you know. And all you would do here is essentially get updated recognitions. If it is not equal to null, return true, meaning you found something. Once you return something, the whole execution is done. All right. Otherwise, if the tries or like the amount of tries you have left is already like 0 or less than 0, it'll always just be 0. All right. You're just gonna stop and you're just gonna return false. That means you did not find the ducky. All right. Now, if neither of these are true, then this sleep time, I'm not sure if you need it. All right. That the sleep time is really just to like keep track of how much time you're wasting running these recognitions, because they might be like really fast, running really fast and immediately, but if your auton can like barely make it, like it can barely like with the autonomous time, like the 30 seconds, like do what it needs to do, then you might want to keep track of how much time you're wasting doing these recognitions, you know. So yeah, that's just to maybe like know, like, all right, run a recognition, wait a few seconds, run another one, not seconds, wait like 0.25 of a second, right? That's what this does. But either way, that doesn't really matter for now. But this is here, right? I'm running find duck again. I'm just decreasing the tries left, meaning you probably shouldn't do this with what is it called? I forgot what it was called. Right? Just this is just a basic code, you know, just to like run again and again for a number of tries until you find something, or if you don't find something, the number of tries it just returns false, right? Now, if you're using two cameras, you would just toggle between your cameras and like run this on both of them. Now, what if you another way to do this without using two cameras and just using one, but not just doing the full zoom, would be using, and this is gonna be, I really don't recommend this because I feel like this would never work, or it might work, but it's gonna be really bad. Using a servo, like imagine you focus your camera only like on one quadrant or like one of your thirds of the camera, and then you just like little by little move your servo, because I'm pretty sure the set zoom, what the set zoom does is like zooms into the center of the camera, meaning you can't like grab your zoom and just like boom, bump and bump. You can't do that. Your zoom is just at the center, meaning if you really just don't like this zoom problem, it's really a big problem, you're just gonna set it to the center, and with a little servo you would move your zoom like here, here, and here. Although, and for moving the servo you just do set position, right? Although I really, and you also have to do sleep so that you give it a little bit of time to move the servo. But I don't recommend this because this is probably going to be really sketchy, more than the other last two ways to do it. So what were the three ways we learned? Well, that I said, you know, just doing the full zoom, it's gonna be sketchy. Doing the part where you have two cameras and you set like one of the cameras like to look at two of the spots and the other one just to look at one, or moving it with a servo. I hope this video was helpful.